Okay, in this math 2, we're going to do actually in chapter 2, we're going to do problems 8, 9, and 11. So for this one, it says plot the following points on a sheet of graph paper, then connect them in the order given. So basically connect points A to B, B to C, C to D, and then D all the way back to A. You should get a rectangle that looks somewhat like this. And then the question is, does the shape you graphed appear to be a rectangle? The stipulation being that it has 4 right angles. And then the question is, in order to justify it, we want to use slope. So from last year, in order to justify that you had a right angle, you need to show that 2 segments or 2 lines were perpendicular to each other. And that's what we need to show in this case. So we need to show that or segment AB is perpendicular to segment BC by showing the slopes for both and how to do that. And then segment CD is perpendicular to segment AD, and then the same thing for segment AD perpendicular to AB. So I'm going to zoom in, and we're going to get the slope from A to B. That's not the distance from A to B, it's the slope. So the slope as you know it, being how much did we go up? So change in y over change in x, that's what we're looking for. So the slope for AB, or segment AB, is going to be segment, okay, so we went up 2, okay, so 2 over, and then we went 1, 2, 3, 4. 2 over 4, better known as 1/2. All right, that's the slope of AB. And then the slope of BC is equal to, let's see, we went down, so 1, 2, 3, 4, 5, 6, 7, 8, negative 8 over 1, 2, 3, 4, negative 8 over 4, better known as negative 2 over 1. Okay, so now we can see these 2 slopes. What happened to my black pen? Well, that's just the weirdest thing ever. Okay, so these 2 slopes are opposite and reciprocal of each other. So opposite being the numbers flipped, right? Numbers, sorry if you can't see that. Numbers flipped, right? Oh my God, that's such a lie. Reciprocal. Okay, sorry, that was my bad. Reciprocal being the numbers flipped, and opposite being that the signs are different. So one is positive, and then the other one is negative. So positive being the slope from A to B, the slope from B to C being the negative one. So they're opposite and reciprocal slopes of each other. Okay, so that means we sure in fact do have a 90-degree angle right up here. All right, now you need to do the same thing with the others. So you need to find the slope of BC, which you should already know, right, because it's not hard to do. Negative 2 over 1, which is what you got, and then find the slope of CD. What is that equal to? Okay, from C to D, or from D, actually it's more like from D to C, but just a heads up, it's going to be positive, not negative. If you're going from C to D, it should still be positive because your line is inclining, not declining. And then you need to find the slope, which once you do, of CD, and then compare it with slope of AD. All right, what is that going to be equal to? And then once you get the slope of AD, compare it with the slope of AB, right? Basically, you're going in full circle. So you need to do basically 1, 2, 3, 4 comparisons. All right, and for each one, you need to verify, is it opposite or reciprocal slopes? And if they are, then yes, you do have a rectangle. All right, where in this case is a 4-sided polygon with 4 right angles. So next one, on part B says, if ABCD is rotated 90 degrees was that clockwise? That looks like clockwise. About the origin to form A prime, B prime, C prime, D prime. What are the coordinates of the vertices of A prime, B prime, C prime, D prime? That's part B. I'm going to need tracing paper for this. Shoot, hold on a second. All right, so we have to rotate this about the origin. The best way to do that is trace the figure. We're going to trace the figure first. There's A, there's B, C, D. Okay, now here's our origin. So I'm going to put a cross right here because we're going to turn this one turn, basically. Here's A. Am I writing on the correct side? Yeah, I'm writing on the correct side. Okay. There's A. There's B, C, and D. Okay, so one turn of this should look like, zoom in, one turn clockwise, it looks like. So we're going to go one turn, there you go, one turn clockwise. So it should look like this. I don't know if you can see very well, but there you go. Somewhere over here. And I'll remove my hand so maybe we can see where they are a little bit better. Anyway, so B prime is here, A prime is here, C prime is somewhere down here, and then D prime is somewhere over there. So write those coordinates in. All right, 9. Okay, we got to break this thing up. So determine the area and perimeter of the trapezoid at the right. And then it gives you a hint. Sorry, I'm on 9. It gives you a hint to recall the formula for the area of a trapezoid, which is 1/2 base 1 plus base 2 all multiplied by the height. So we're going to be working a lot with this formula. So base 1 plus base 2 divided by times the height, and all of it times 1/2. Or I kind of do it this way. I do B1 plus base 2 times the height up here, all divided by 2. That's pretty much the same thing. I just like to work this one better because then I don't have to multiply by 1/2. I just take all that and divide by 2, which is the same thing. It's just easier for me to remember this way. All right. Here we go. Determine the area. Okay, that should be the easiest thing to do. So this is going to be B1. Let's say the one on top. It doesn't really matter. They're both B1. You can make this B1, that B2, doesn't matter. That's going to be my base 1. This is going to be my base 2. My height is what makes it perpendicular with the top with the bottom. So the height is not square root of 20. Okay, the height is actually 4 millimeters because the height is the one that makes that 90-degree angle. That's the altitude of the trapezoid. So this is H. All right. So if I take all this information, I should get base 1, so 5 plus 8, okay, all in parentheses, multiplied by 4. That's my height. That's where it came from, right? And then all of this divided by 2, and what's 5 plus 8? I don't even know. What is that? 10 plus another 3, so 13 times 4 all over 2, and I'm sure you can work that out. And since we have meters here, whatever you get for your answer should be meters squared because we're talking about area. All right, now perimeter. Perimeter is the outside of the figure, right? So basically everything that I am highlighting in yellow right now. All right, so we have 8 and we have 5 for the top. The side length is the square root of 20. So we need this part right here. Right now I'm going to caution you, it is not the square root of 20. So this side over here is not square root of 20. You need to find out what it is. So this is going to involve a two-step process, actually. The first step is we need to figure out what this bottom piece is right here. I know that sounds kind of silly, but that's like the only way to get there. So we can work this out. All right, this is involved. So I think I'm going to take this picture and I'm going to recopy it down here because I kind of need it bigger. Let's see. I'm going to redraw this because I need it bigger. That way I can talk about what's going on. And then this is 4. I'm going to drop the units just for right now because it'll make things go back faster a little faster. Okay, so this is what we have. We need to get here. Okay, we'll call that X. Now, in order to get here, we need to break this apart. So the way I break this apart is I say, okay, well, this piece right here, all right, there's this piece right here, and lo and behold, it's the same height of the trapezoid, so this must be 4 also. But I don't know what this is. I do know this piece is 5 because it comes from the top part, but the whole length is 8. So until I figure out what this piece is, and you can do that, it's a mathematical thing. You could figure out what this piece is, and then this is 5, and that should give you the remainder here. So I'm going to call this piece Y. Okay, and that's going to be another right triangle right here. This, I hope you see right here, is also a right triangle. And it actually gives you that in the original picture, right? I just forgot to copy the little right angle. Now, in this piece right here, this is your hypotenuse. This is going to be your leg. And you have another leg right here. Well, I don't know what this leg is, but I think we can figure it out. Since it is a right triangle, we can do Pythagorean theorem. So let's do that. Leg squared plus leg squared is going to give you your hypotenuse squared. So leg squared plus leg squared, hypotenuse squared. I'm not going to call this X because I called this part X. That was my end goal. And I already used Y, so I'm just going to call this, I don't know, T. Okay? So I have leg squared plus leg squared. So 4 squared plus T squared is going to equal the square root of 20 squared. All right, well, 4 squared is 16 plus T squared, I don't know. The square root of 20 squared is just 20. If you're not sure why, please use your calculator. Otherwise, the only thing I can tell you is, since this is a square root, when you square it, it undoes the sign, basically. So now we have T squared is equal to 4, because I'm subtracting 16 from both sides, and you have that T is equal to 2, because the square root of 4 is going to give me a 2. So that means T over here is 2. So if this is 5, and that's 2, together 5 and 2, just for this part, should give you a 7, right? But the whole thing is 8. So if that's 7 just from this little corner right here all the way here, that means Y on this side must be equal to 1, because 1 plus 5 plus 2 should give you 8, which is the whole entire bottom from here to here. Okay, 8 was not just this top part right there. So 1 plus 5 plus 2 should give you 8. Now I know this is 1, this bottom piece right here. Okay, this is 1, and then this is 4. So I'm going to do the same thing that we did on the other side with the right triangle. I'm going to say, okay, well, if this is 1, this is going to be my leg, this is going to be my other leg, and this is my hypotenuse. So now I have 1 squared plus 4 squared, and that's going to give us our x squared. That's the one you wanted. So 1 squared is just 1, plus 4 squared is 16 equals x squared. So we have 17 equals x squared, and so I'm going to take the square root of both sides, and since 17 is not a perfect square, it's just going to stay as the square root of 17 as my answer. Okay, so the hypotenuse here is going to be the square root of 17. That is the length. You can probably get that as a decimal, but for right now we're just going to leave it as a square root of 17, since on this side it's also listed as a square root of 20, not as a decimal. So our perimeter, final answer should be add everything on the outside up. We have 5 plus 8 plus square root of 17 plus the square root of 20. All right, so that stays as 13 plus square root of 17 plus square root of 20. Done. And if you're wondering why I'm not putting 17 and 20 together, is because it is not allowed. It is illegal to put those two things together since they are not the same. Okay, those are two completely like terms. And then I think that should be, oh no, we have another one, right? Yeah, I think we have another one. Let's see. Oh, 11, right? Okay. Missy's building a triangular planting bed. The two lengths of the length, triangular planting bed. The two sides of the lengths have lengths of 5 and 8. Okay, what are the possible lengths for the third side? All right, well, she's just pretty much doing a triangle, right? So one of them is going to be 5 feet. The other one's going to be 8 feet. I guess the only question is, what can you build here? So this basically goes to the learning log that we had the other day. The smallest, right? The smallest she can make is 3 feet. And then the largest that she can do is 13 feet. So she has to make her third side somewhere in between. Well, it has to be somewhere in between 13 and 3 feet. Okay? All right. So that takes care of that homework. If you have any questions, I will see you at lunchtime.